Good afternoon, students. Hello?
Afternoon, sir.
All right. Can see the screen clearly and everything, right?
Yes, sir.
All right. So I sent 3 questions to the group today. I'm just going to work through those 3 questions now, and hopefully persons would have done them and will learn from your mistakes. If you did not do it, no problem. You can still go and do it even after I do it. Bottom line is that you must do it. All right. So this is the first one. This is on the June 2017 paper. It's a bearings question. 10B, and it's a bearings question, and let's get right into it. All right, so let's go. So it says a ship leaves port A, this is port A, and says 52 kilometers on a bearing of 044 degrees to port B. And this is port B. So it's telling us about the journey this way. The distance is 52 kilometers, and it went on a bearing of 044 degrees. It means that this line is on a bearing of 44 degrees, 044 degrees. So again, this is the from position. We're going to show that information on the diagram. This is a north line. I'm just going to extend it. All right, thanks. You have you balance up the other thing. All right, can I just carry commotion? That's a north line. I'm just extending it for the purpose of the diagram. And then it is a clockwise angle. So it's like we stand at this from position and we have to turn to the right 44 degrees. So the bearing is 044 in order to face B. That direction is on a bearing of 44 degrees or 044 degrees. So this angle inside here is 44 degrees. It is 044 degrees is a bearing. 044 degrees. And this distance, they tell us that distance is 52 kilometers. I want to put it on it as well. 52 kilometers. 52 kilometers. All right. That's the information so far. The ship then means afterwards, it then changes its course to port C. So from B now, it's going to port C. So it's now talking about the movement from B to C. So B is now the from position for this part of the movement. Port C is 72 kilometers away. That's this distance. And the bearing that is going on is 105 degrees. So this direction is on a bearing of 105 degrees. So again, this is from here. And so we face north first again. And it's the angle through which we have to turn to the right, clockwise angle, to face C. All right, cool, we talk. To face C. So this is the angle that is 105 degrees. So I'm just going to put it on there. Let me extend this line again for the purpose of the diagram. And I'm just going to put the end up here instead. And so the angle that we want, this angle, when you turn to the right, that angle is 105 degrees. That's the bearing. Let's put 105 in here. 105 degrees. And the distance is 72 kilometers. That's the distance on this here, BC. So 72 kilometers. So you see the situation is the same with almost every question. We have 2 sides of that triangle, or 2 distances. What we don't know is this side. So the question must ask us for this distance. And so if we can find the angle between here, between these 2 sides, if we can find that angle, then we can use cosine rule. 2 sides and the angle between. Cosine rule will give us that side. All right, some questions will ask us for that angle. Some questions will not. All right, but we know that we need that angle. We need this angle. All right, so this question says we have to determine angle ABC. That's the same angle that we needed to ask us to find. All right, now I'm going to show you 2 ways to do it. One way to do it is to actually break the angle with this vertical line, this north line, break it like that. And then what you see is that on the right side over here, total angle on a straight line is 180 degrees. So since this is 105, it means that inside here is 75 degrees because they must add up to 180. So the 75 is really 180 degrees minus 75. Minus 105, sorry, minus 105. All right, that is how we get the 75 degrees. And then now on this side of that angle, we see a Z. We're working in a Z. Let me mark out the Z in purple. This is a Z up on this line, down here, up on this line. See, this line, these are two north lines. So they are parallel. And so we have the Z angle. So this angle inside here is actually equal to this 44 degrees down here. They are alternate angles. All right, so recognizing that Z, the angle inside here is 44 degrees. All right, let's put it down in red. This is 44 degrees. I think the pen is a little bit too thick. 44 degrees inside here. And so now we know the total angle across that side. Let's put it in purple. The angle ABC that I want, this angle, is the sum of those two. It is the 74 plus the 75 plus the 44. Right? And so that would be 119, yes, 119 degrees. And that will be it. 119 degrees will be this angle here. That's one way to do it. All right, so it is 119 degrees. Another way to do it, I'm going to show you another way quickly. You can always undo. I prefer this way that I just did. I prefer this way, right? The other way to do it, if I take these off, is to work with the co-interior angles over here. So put it on in red. So this line again is parallel to this line, and this line is connecting them, joining them. And so it's like we are formed out of U, the U angles. All right, I spoke about co-interior angles. So the angle down here, which is 44, and the angle up here, they add to 180 degrees. And so we can find this angle by doing 180 minus 44. So let me undo all of this. 180 minus 44. So this angle would be 180 degrees minus 44 degrees. First, it says subtract 40. First, get 140, subtract 4 more. So it will be 136. So it should be 136 degrees. And then now to find this angle, we would say total angles around this point B is 360. And so the angle right here would now be 360 degrees minus these two, minus the 136 and also minus the 105 degrees. And that should give you back this 119. And let me just double check that right here just to make sure. You can check it as well. It would be 360 minus the 136 and minus the 105. Good, we get the same angle. So that's another way we could do it, but I'm going to go back to the original way, which is my preferred way, which is to break the angle. I prefer to break the angle as I did, and I would have that. I prefer that way. Right? When I break the angle with this vertical line down here, extend that vertical line. On this side, total on the straight line is 180. So get the angle side here. And on this side, we see the Z angle on this side. So get the angle right here is equal to the angle over here, 44. All right, so I prefer that method. I think it's a little bit quicker. All right, so that angle is 119. And now that we have that angle, we can use cosine rule to find this side, which I'm sure they're going to ask us for that distance AC. See there? The distance AC. So the nearest kilometer means that they don't put any decimal. They just give to the nearest whole number. So even though it's further down here, I'm going to put it on this page where the diagram is located. I'm going to put it right here, the calculation, right? So we're now using cosine rule. So cosine rule for AC. And again, we're using the cosine rule because the typical case for the use of the cosine rule, which is two sides and an angle between them. Remember, you can only use a sine rule when you have an angle and a side in a triangle that are opposite to each other, and you know both of them. You have to have a pair of angle and side that are opposite to each other, that you know the values, you know the angle and you know the length of the side. The one angle that we know, we don't know the side opposite. And so we cannot use a sine rule, and so we have to use a cosine rule. All right, but then as I said, this is a typical case for the cosine rule. Two sides and an angle between. So the side over here that we want, you start out like Pythagoras' theorem. It will be AC squared equals this side squared plus that side squared. That is 52 squared plus the 72 squared. That's what it would be if this angle was a right 90 degree. But it's not a right angle, so you have to subtract a piece. You're subtracting twice the product of the two sides, which is 52 times the 72 times the cosine of the angle between them. The angle between them is 119 degrees. Now, instead of putting the square on this in the cosine rule, we could actually do it, leave off the square, and then put the square root over all of this. And by doing that, we would skip a line. We would save ourselves a line. So I want us to practice to just do it like this. And it's just a matter of plugging this in the calculator, and that would give us AC in kilometers. Let me bring up the calculator and see what it is. Let's see. Let's find the calculator over here. Here it is. All right, so I'm going to put that in the calculator now. And it's going to be the square root of 52 squared plus 72 squared minus 2 times 52 times 72 times the cosine of the angle between them, which is 119. All right, let's just make sure it's 52 and 72. Yes, it is. And so the length there is 107.3, but because I said to the nearest kilometer, we're just going to put 107. That's the nearest whole number to have the distance. All right. So we now know that AC is 107. So I'm going to put on the diagram there. Let's write it over here. I'm putting the equal in front of it because it is something that we worked out. It is 107 kilometers. So now we now know the three sides in that triangle, What we don't know now are this angle and this angle. And any one of them we need to find, we have to use a cosine rule. We can use a sine rule. Any one of those two angles now, we can use a sine rule. All right. And more than likely, the question is going to ask us for a bearing from this point, or from this point. Let's see. They usually ask for a bearing angle as well. Let me copy this down and move it down, this thing. Let's move this thing down. Let's cut it. Paste it down here where it belongs, right here. All right. That's there. See, they want a bearing. They want the bearing. Let's see what they want. They want the bearing of A from C. And remember, you always make note of the from position. So you're doing the bearing at the from position. So it is from C to A we want. So you're going to measure the bearing at the C. Oh, this one wants us to show that it is 260 degrees to the nearest degree. I like this because I know the answer. So it's for us to calculate the bearing, and when we calculate it, it must be 260. All right, from C to A. But let's show what this angle would be on the diagram. Bearing from A to from C to A. Bearing of A from C. C is the from position. So let's see which angle they're talking about. So C is the from position. Let's do that part in purple. That angle. I want the bearing from here down to A. All right, from C to A, the bearing of A from C. So the bearing must be measured here at the C position, right? So it is like it is like we are at the C position, and we're going to face north first. And then now it's an angle through which we have to turn to the right in order to face A. So the bearing angle that we want is this angle. Now, a good thing to remember is that 99% of the time, if you want the bearing in these questions at this point, then the angle inside the triangle at that point will play a part in the calculation. So I usually just go and call it alpha, because I'm trying to do the question the same way every time, so I don't have to think. So I know that this angle should play a part in the calculation, and I have to use sine rule to find it. And then the angle that I want is this one, which I'm now going to call theta on my diagram, so I can reference them, use these angles or these symbols to represent what I'm trying to find. So this is the bearing that I want, and this alpha will play a part in the calculation. So right now, the only angle that's missing to complete a circle around the point C will be this angle inside here. Let's put it on in red. This angle right here. So this angle plus the theta plus the alpha will be 360 degrees. And so the theta will be 360 minus these two. Now I know I can find this one using the sine rule. But what is this one? This one is a co-interior angle with that one. Because remember now, this line and this line, they are parallel. They are two north lines. They are connected with this line BC. And so you see we're forming a U again. The U angle that we spoke about. They are called co-interior angles. They are like angles in the base of a U. So these are the two angles. All right. And so this angle right here will be 180 minus this one. But another way you could see this angle here is, if I do this now, let me remove this. Then I could say I have this line down here. I come up on this BC. And then I have this line down here, which is parallel. So this one and this one parallel. They have two north lines. And so we have alternate angles now. So this angle inside here is actually equal to this one. Those two angles are alternate angles. Angles in the Z angles. So therefore I know that this angle is actually 75. I think that's the easier way to recognize that it is actually 75. So let me clean up the diagram. So this angle is alternate to this one, and so it is 75, and so I can put the 75 degrees on it. 75 degrees. All right, so the theta here that I want now is going to be equal to 360 minus the 75 and minus the alpha. I'm going to do the calculation right here and then copy it down again. All right, let's make this a little larger. All right, so let's go. Let's work it in purple. So I'm going to tell the examiner bearing. I'm referring to my diagram now. Bearing of A from C is actually the angle theta on my diagram, which is equal to 360 degrees minus the 75 degrees and minus the alpha. And I have to work out alpha, doing it the same every time. So I know I'm using sine rule for alpha. So I'm telling the examiner I'm using sine rule. Sine rule. All right, guys, let's answer this card quickly. Hello? Mm-hmm. Mm-hmm. But it's the same thing that we do. When we're on the insurance report. It's by location. The insurance report that I send each time. You say inventory by location. Yeah, that's what I normally give. So it's just a MB52. This is MB52. MB52, and I put in the plant, and then I don't put any location. So it gives me all the location that way. Yes, current. Oh, that's MB5B. If you want the hazard. Yeah, it's kind of limited. Right. I think we have some issue with that, because the one that we used to use before was MC.9, right? And MC.9 not functional anymore. Yeah, MB52. But you're not gonna get it at any particular date. It's just current. So what I have to do to ensure that I capture certain particular days, ensure that I run it on those days. So for example, at the end of the month, I have to ensure that I run it at the close of the month to get the close of year inventory. All right. They give you SIT as well, give you everything. Yeah. Yes. All right, cool. Yeah, man, cool. All right, guys, sorry about that. It was work, and you have to bear with me, because sometimes I have to do work. All right, thanks. Gano? Huh? The one in there? You want to take it out of my car, sir? Can I get it out now? Kevin know what it is? You might know what it is, I'll make sure I get it later or tomorrow. Yeah, the gate pass with the desk here. The gate pass is on your desk? Oh, you never write up yet? All right, cool. Right now? No, you come, send me a message and remind me, please. All right, guys, sorry about that. Work again. All right. So, all right. So here now, remember, we have to use a sine rule to find the alpha. So it is start with what you want, right? So using the alpha across from the alpha is the side 52. And we're also using this angle that we know across from it is a 107. So that's how the sine rule works, right? So if I want to find the alpha, we're going to start with sine of alpha. Make the transposition easier to do. Over the side opposite to the alpha is the 52, not 25, 52, which is equal to sine of the angle that you know now, which is 119 degrees. Over the side opposite to that is the same side here, 107 that we found. And that's why it's good to always put the information on the diagram as you calculate it. It's 107. They were trying to make alpha the subject. You see, they don't give a lot of space to do this work, guys. Well, this is not the right space for this question, but anyway, they don't give a lot of space. We don't have time to do 2 and 3 steps of transposition in these questions. So it's a matter of multiplying this 52 up here, and then we take the inverse sign in front of it. All right. So we're going to multiply the 52. So the alpha is going to become sine to the minus 1 of the 52 times the sine of the 119 degrees over the 107. All of this in a bracket. All right. That's what we're going to have. And you're going to put this in the calculator. We're going to get the alpha. Let's put that in the calculator now. So it's sine to the minus 1 of a fraction. It's 52 sine 119, calculated in degrees, yes. And we're dividing that by 107, and we get 25.1 degrees. Well, these are all whole numbers, so I don't need a 0.1. I'm just going to put 25. All right. For the question did say we are showing that the angle is 260 degrees. So I'm going to put the 25. And so this 25 is going to subtract it up here. I'm going to use it back up here. Right there. So going back now. And so therefore, the bearing angle that we want, theta, becomes 360 degrees minus 75 degrees and also minus 25 degrees. 75 and 25 is 100, guys. So it's easy. It becomes 360 minus 100, which is then 260. So the theta angle is actually 260 degrees. And that was shown. It was a shown question. That is it. Let me copy this down and put it in its rightful place. Yes, I cut it. Put it down here. So many marks was there for it right here. See, still not a lot of space to work. All right, as you can see, not a lot of space to do these questions. So we have to be very efficient in our work. But that is it, guys. That finishes this question. But okay with that?
Yes, sir.
So if you didn't get it right, you learn from your mistakes. And if you got it right, good. You know that you're doing good. All right. The next one was, I think, 2015. I don't think there was a bearings question on 2016. So I think the next one I sent today was 20. Let's see, 2016. I don't think there was one on 2016. Let's see. All right. I think there was an elevation question. 2016, which is a topic we're going to start with in January. Elevation, yes, there it is. The elevation question, not a bearings question, right? So every so often it might bring something else, but the majority of the time that you will get is a bearings question. All right, so 2015 was the next paper that we did. And I think we can write on this one. All right, there's no space. Oh, yeah, there is. Okay. So 2015 bearings question. There it is, right there. All right, let's go. Here we go. Bearings question again. So you see, keep giving you a diagram, making it easier for you. In previous times gone by, we would have to draw a diagram from scratch. Majority of the questions now, they give you the diagram, so they're helping you. This question says, the diagram below not drawn to scale shows the relative portion of three fishing boats, K, L, and M. So K, L, and M, three fishing boats. All right, it says L is on a bearing of 040 degrees from K. So from K to L, from K to L, the bearing is 040 degrees. So from K up to L, 40 degrees. So this line is a 40 degrees bearing line. So it is this angle. Stand at the front position, face north first, angle through which you have to turn to the right. That is the 40 degrees. So let's mark it in red. So let's just mark it like this. This will be a 040 degrees. 040 degrees. And they gave us a distance on the diagram as 8 kilometers. Then it says, and M is due south. Now, due south just means towards the south. Towards the south. The word due south means towards the south. So basically what it is saying is that to go and off means from. Off also means from. So I don't want you to get confused. So in other words, from L to M, you go due south, means that you go towards the south. So this line then is a north-south line on the diagram, this one. Right? This is a north-to-south line down here. Right? Right? So from L to M is a north-south line. So it means that this line is parallel to this line. That's a north-south line as well. And so if I connect them with this, then I have a Z. So these are alternate angles. So it means that the angle inside here is also 40 degrees. Now we're good to go. So we can put that there because of the Z. This angle is 40 degrees. Because it is alternate with this one. These two angles are alternate angles, Z angles, because you have to recognize that this is a north-south line. All right, it's parallel to this one. These two lines are parallel. So we have the Z. All right, enough said about that. And so we have an angle inside the triangle. So we can find this side now using cosine rule. This question is really very easy. That's what it wants us to do. It says on the diagram, show the 40 degrees, and that's what we did here. So the part is answered. Then they want us to calculate the measure of this length. The measure just means the length of it. Oh, the angle, sorry. Calculate the measure of this angle, KLM. It is 40 degrees. Another easy question. The Z angle is equal. So we're just going to write it is 40 degrees. Z angles are equal. One mark. See? 40 degrees. All right. I'm just going to put the reason. Z angles are alternate angles. Z angles are equal. All right. Let's put the reason in there. Why we say it is that. And instead of saying alternate angles, Z angles are accepted. It's okay for you to say Z angles. All right. If you want to be sure, you write alternate angles. Then what us calculate the length of this side, the KM, which is going to be with the use of cosine rule for sure. Because again, we have two sides and an angle between them. All right. So let's do it here. I can do it beside it and then copy down. Let's do it. Let's see if I can fit everything. All right, let's do it this way. So we're just going to write it out, cosine rule. For KM. Notice I don't give a lot of space for it to work. So when I write this KM equals, I must see it now, the square root. And we would normally have a square here, we put in a square root on this side instead. All right. There's going to be the 80 squared. That is this 80 squared plus this 120 squared. And you have to subtract a piece. You subtract 2 times the 80 times the 120 times the cosine of an angle between them, which is the 40 degrees. And you put this in the calculator and you get KM. You see, you don't have a lot of space to do a lot of work. See, a very small space. This is proving to you that you have to be efficient with your work.
78, sir.
78 you get? Thank you for that.
Yes, sir.
All right, beautiful. Make it easier for me. Very good. So that is 78 kilometers. And because it's set to the nearest kilometer, even if you got decimals, you don't put the decimals. You run it after the nearest whole number. That's what I mean by the nearest kilometer. Nearest whole number, 78. And as you know that it is 78 now, you put on the diagram. You want to see information on the diagram. So this side is now equal to 78 kilometers. So now we know the three sides. And we also know this angle. Only thing we don't know now for this triangle is this angle and this angle. And we can find any one of them with the sine rule, because we now have this pair of angle and side opposite each other, where we know both of them. That's that side and that angle. Once you have that pair in a triangle, you can use the sine rule to find other stuff. So if I want to find this angle, I would pair it with this side over here. So remember, to use the sine rule or the cosine rule, you have to know three things and find a fourth thing. So these three things that I've circled will be three things that I know, and I could use those three things to find the angle inside here. All right, but let's see what they want us to do. Let's see. Let's not preempt the question. Let's see what they want. Usually they would want a bearing. It says calculate the measure, okay, of angle LKM. All right, the point is at angle is at K, LKM. Same angle that I want, LKM. So this angle we're talking about. So I'm going to call it alpha so I can make a reference to it, because more than likely we're going to use it next. Let me work in purple now. So I want to find this angle inside here. I'm calling it alpha. And I'm going to use a sine rule. We can put it right here. All right. So using this pair with this pair. So sine rule for the alpha, which is the angle LKM. I'm going to state that on the next page. There's going to be that sine of alpha over the side opposite the alpha is 120 equals sine of the 40 degrees that we know up here over the side opposite to it, which is the 78. And then to make this a subject, we're going to multiply the 120 and then take the inverse sine All right, same thing every time. So the alpha becomes sine to the minus 1 of 120 sine of 40 degrees divided by the 78. And put that in the calculator. Anybody works it out? Can tell what it is? Anybody got it? Person who got the 78, they didn't do it this way.
So I got 81.
81, I got
81.4.
81.4. All right, let me just check it
So
now.
81.5.
I remember when you're giving the answers in degrees and they don't tell you how accurate you want to give it, you give it to 1 decimal place. See, and this to the nearest degree again means that they don't put in the decimal. When you say to the nearest something, it means that you're not going to put in the decimal. You just go to the you just go to run it after the whole number. Run it after the nearest whole number. That's what I mean by to the nearest degree. You don't put no decimal on it. But let's work it out. Oh, let's work it out over here. So it's going to be sine to the minus 1 of the fraction 120 sine of 40 over 78. So it's 81. So it's 81 degrees to the nearest degree. 81 degrees. I want them to the nearest degree. So I'm going to copy this down now. I'll cut down paste. Paste it where it is supposed to go, right here.
That would be correct, sir. The 81.
81 degrees, yes.
You can
Someone?
the 5 right after the 4. That round up, that'd be 5. And then 5
No,
that
you're
round
only
up.
rounding off the 1. You're only rounding the 1.
Okay.
So if you have
Okay.
81.4 and you need to correct this, you have to use the 4 to correct it. Even if you have a 9 come
Okay.
here, so I can't use the 9 and correct this. I can only use the 4 that is here to correct this. I don't care that the 9 is going to turn the 4 into 5. Use the 4 that is there to correct that. And it cannot correct it. 4 can't increase 1. Okay?
Okay,
All right,
sir.
good. All right, good. So the angle is that. I'm going to tell the examiner here that the angle is alpha. So angle LKM, I'm calling it alpha. All right, just let the examiner know. When I calculate alpha down here, it is the actual angle that I want. But I would have also had it on my diagram. Right? And so they will give you a mark anyway. They want to give it a mark, you know. They don't want the bearing of M from K. Bearing of M from K. Again, always, guys, make sure you know the from position. The bearing is measured at the from position. So it's from K to M. Go on. Look at the diagram and see what that angle is. So K is the from position. Let's go. So K is the from position. All right. So this is the from position. Let's do this part in blue so it can stand out for us. So you want the bearing from here down to here. So again, stand at the from position. Face north first. It's the angle through which I have to turn to the right. Let me take these out. Angle through which I have to turn to the right in order to face M, one here. So it is that blue angle that we want, that I've just marked, that blue angle. This angle right here. And that angle clearly is the sum of these two. Right? So if we call that bearing angle theta, then theta is equal to 40 degrees plus alpha. Where alpha was 81, right? So that's 40 plus 81 degrees. And so it is 121 degrees. That is the bearing angle that we want. Let's tell the examiner. Bearing of M from K is theta, which is 40 plus alpha B from the diagram. And I'm leaving all these things on my diagram, you know, guys. All these markings that I put on the diagram, I'm leaving them. Right? Because I'm using these symbols for my reference. Makes the solution clear, makes the marking by the examiner easier, because everything is referenced and clear. Okay, so get into the habit of doing that. All right, you want to make it easy for the examiner to mark your paper. So See, it was an easy question, so that's why it's only 1 mark. You basically just adding those two angles to get it. That is it. Very good.
Yes, sir.
All right. So there's a short session, you know. That's the 3 questions that I sent here that I'm doing today. So the next one was on 2014. 2014. 2014. Which is this one. Let's see. Let us see. 2014. I think we're gonna need a page to write on. I don't think we can write on the paper itself. 2014. Yep, that's correct. I need a writing space. All right, there you go. All right, let's split the screen. Mute the mic, please. Mute the mic. All right, one last question and then we can call it a day. One last question today. All right, so give us this diagram. You can see it's a bearings question again. It said the diagram below, not drawn to scale, shows a portion of 3 ports, P, Q, and R. All right, it says Q is 80 kilometers from P, and we can see that right here. All right, Q and P, 80 kilometers apart. And R is 100 kilometers from Q. R is 100 kilometers from Q. That also is on the diagram, which is good. But they tell us that it's on a bearing of 0.66 degrees. So from Q to R, the bearing is 0.66 degrees. So from here to there, the bearing is 0.66 degrees. So again, it's like you stand at the front position, let's do it in red, and you face north first. It's the angle to which you have to turn to the right in order to face the position that you're measuring the bearing to. So this is the angle that is 66 degrees. So we can put it there. 0.66 degrees, this angle is 0.66 degrees. That's the bearing angle. And so they give us this angle inside here. They're helping us because we can use no cosine rule to find this side over here. All right, with that 54 degrees angle. They tell us the angle inside is 54. We want to calculate the bearing of P from Q. Let's go. So from Q to P. So Q is the front position. We're going to P. So again, it's kind of easy. But they're gonna stand at front position, face north first. This is the angle through it. What happened, guys? Hello? Yes? You mean the dumping? No, because I gave them a task to finish an excessive amount in a short time. Otherwise, I would have to come back for another week. That's what happened. They doubled? Is a double rate? I agreed with them a double rate to finish the job. Yeah, I agreed with them to double the rate. Otherwise, we'll have come back for one additional week. Just them, man. Just how this one. No, just a one off. Just that one off. Yes. All right. Yeah, man. Cool. Yeah, thanks. Yeah. All right, cool. Thanks. All right, guys, sorry about that again. All right, so at the from position, the bearing down to R, we have to, at the from position, face north first, and then it is the angle through which have to turn to the right all the way around here until the face P. So the angle that we want is this one that I've drawn in blue, which clearly is the sum of these two. All right, obviously that's the sum of those two, that blue angle. Let me leave it. That bearing angle in blue is the sum of those two angles, 066 and 54. That is what will answer this part of the question. So this is equal to 066 degrees plus 54 degrees. What is that equal to? 120
degrees.
120 degrees. And it's 3 digits. Good. Then I want the distance, PR, corrected 2 decimal places, right? So it's the only distance that we don't have, which is this one. This one. And so we're going to use cosine rule because, again, what we have are the two sides and the angle between them. So we're going to use cosine rule to find this side. We need 3 things to find a 4th thing in cosine rule. All right. So we're going to use cosine rule. I can write it up over here and say cosine rule for PR. All right, and it's going to be, again, we don't have to put on a square. It's going to write PR equals the square root of the 80 squared, that's this side squared plus this side squared, plus 100 squared, like Pythagoras' theorem. Start out like Pythagoras' theorem, then subtract a piece. Subtract twice the 80 times the 100 times the cosine of the angle between them, which is 54 degrees. So all that it is instead of putting the square on this, we have instead put the square root over there. So it eliminates one line of work or one step. And so PR is equal to something kilometers. Anybody worked out this one?
83.64.
And that's what I said. 2 decimal places. 2
Yes,
decimal places. Good. So tell me now.
83.64.
83.64. Beautiful. Beautiful. So this is equal to 83.64 kilometers, and always put it on the diagram. So everything is in front of you. So this side now is equal to 83.64 kilometers. So we now know the 3 sides in the triangle. We also know this angle. So the only thing we don't know now is this angle and this angle from this triangle. And any one of them we want, we can use the sine rule now because we have this pair of angle and side that are opposite to each other, where we know both of them. All right, so we can use sine rule to find any one of these two angles now. So for example, if we want this angle down here, we're going to pair it across here in the sine rule. And again, it's 3 things to find a 4th thing that you'd have to know. Would know this, this, and this to find that if you're using the sine rule. All right, but let's go. Let's see what they actually want us to do. Let's see. All right, most times they want us to find a bearing or an angle. All right, see, calculate the measure of angle QPR to the nearest degree, meaning don't put any decimal on it. Angle is at P, QPR, QPR. That's this angle they want to know. That we said that we need. Man, we want this angle. Let's put it on in blue. QPR is this. We want to call it alpha. All right, and we're going to use the sine rule to do it. So we're going to pair these two. We're going to pair these two. All right, so let's do it right here, over here. So we're going to see sine rule. Let's put a line across here. It's a sine rule for the alpha. Start with what you want. Sine of the alpha over the side opposite alpha is 100. equals sine of the angle that you know, which is a 54 degrees, over the side opposite the 54 degrees is 83.64. And they ask you for two decimal place. You have to work with the two decimal place that they asked for, right? We're going to multiply this 100 up here, and then we're going to take the inverse sign. So if you notice, we're doing the same thing almost all the questions. Alpha will be sine to the minus 1 of 100 times sine of 54 degrees divided by 83.64. All right, and that's why it's so important for you to practice, because they're basically asking the same thing to do. It's almost like the same thing we do for all the questions, you know, just different angles, different distances, but we're practically doing the same thing. Anybody worked out this one? Anybody work this
75,
out?
sir.
75. So you're gonna put the 75 degrees. And it's not a bearing, it's just an angle. So you leave it like that with the 2 digits. And that finishes this question. It is 75 degrees. And that's it. And we're done for today. And I can go back to do some work because I'm still busy at work, as you can see. All right. So thankful I was able to have this session today. But okay. So 1 hour
Yes,
session
sir.
or less. But that's good. All right, beautiful. So those of you who did not do it or you got something wrong, you just need to go and redo the question. All right, redo the question, learn from your mistakes. All right, so the aim is to have another session on Saturday. Maybe we'll do some more bearings, or maybe we'll do some general revision. We're not going to be doing anything new until January comes around. Nothing new while we're online only. All right, so that is that. All right, guys. If I don't talk to you, well, we're gonna meet before Christmas. We're gonna meet before Christmas. So let me not say Merry Christmas yet, because I know we're gonna meet before Christmas, maybe 2 times before Christmas. All right. So bye, everybody. Have a great rest of the evening. I'll send the video into the group right away. All right. Bye, everybody.
Bye, sir.
Okay. Bye bye.
Goodbye.
Bye bye.